Welcome to my video lecture series in Object-Oriented Programming. This is Professor Janice Raymond Tan from the College of Computing and Engineering.
For this video lecture, we will cover the topics about a class relationship, which is class association. Throughout this video, we will discuss what is class association, multiplicity, association representation using UML class diagram, and how to translate class association into actual code. One of the advantages of object-oriented programming language is code reuse. This reusability is possible due to the relationship between the classes. Object-oriented programming generally support four types of relationships that are inheritance, association, aggregation, and composition. All this relationship is based on is a relationship, has a relationship, and part of relationship. Throughout this video lecture, we will focus on has a relationship, which is the class association. What is class association? If two classes in a model need to communicate with each other, there must be a link between them, meaning class relationships are only applicable if you identified a link between two classes, and that can be represented by an association or a connector, and this is represented by a solid line. Association can be represented by a line between these classes with an arrow indicating the navigation direction. In case an arrow is on both sides, the association is known as a bidirectional association. Association is a has a type relationship. Association establishes the relationship between two classes uh, using through their objects. Association relationship can be 0 or 1, 1, 0 or many, 1 or many, and many to many. This association relationship is known as multiplicity. Keep in mind that class diagram showing class relationships is different from the ER diagram you are using on your database management course. We indicate the multiplicity of an association by adding multiplicity adornments to the line denoting the association. In object-oriented programming, an object communicates to other objects to use functionality and services provided by that object. Aggregation or weak association and composition or strong association are two forms of association. Factors to consider to identify as class association. We call association those relationships whose objects have an independent life cycle, meaning an object of a class can live on its own even when deleted one of the two objects. No whole part relationship, no object of the class is considered the whole and the part between two objects. There is no ownership, meaning one class does not own another class. And lastly, child objects may and may not belong to another parent object. Multiplicity. Multiplicity can be set for attributes, operations, and associations in a UML class diagram, and for associations in a use case diagram. The multiplicity is an indication of how many objects may participate in a given relationship, or the allowable number of instances of the element. Possible values, for example, the first entry in our table, 0 or 1, meaning it indicates that 0 or 1 entity type instances exist in the association end. Another one is 1. It indicates that exactly one entity type instance exists at the association end. 0 or many, meaning it indicates that 0 or more entity type instances exist in the association end. 1 or many indicates that one or more entity type instances exist at the association end. Association representation in UML class diagram. Associations are always assumed to be bidirectional. This means that both classes are aware of each other and their relationship unless qualify the association as some other type. The given figure shows the relationship of a person and a driver's license class. Notice the straight line between classes to indicate association as the type of relationship. Multiplicities such as 0 or 1 and 1 are used in this example. The relationship will be read as follows. So let us consider first from person to the driver's license class perspective. So we will look at a person towards the driver's license class perspective at this moment. So according to the figure shown, from person to driver's license, every person may or may not have, that is 0 or 1. Again, every person may or may not have, that is 0 or 1, have a driver's license as shown in the figure. In real world scenario, it is not required for a person to have its own driver's license, and that is the 0 here in the 0 or 1 multiplicity. Additionally, a person can only have one driver's license, that is the one in 0 or 1. Again, from person to driver's license, you will take a look at this multiplicity. Okay, not this one. From person to driver's license, take a look at this multiplicity. From driver's license to person, you will take a look of this multiplicity. Going back with our discussion again, a person can only have one driver's license, and that is the one in 0 or 1 multiplicity from person to driver's license for his entire life. So combining the two cases makes it 0 or 1 relationship. So from person to driver's license, we will use association following multiplicity, which is 0 or 1 multiplicity. Next, to achieve association and to make every person object aware that he or she have an driver's license, you need to define a driver's license object as a class field of the person class. So as you can see in the given figure, inside the class fields or the second compartment of our person class, we defined a driver's license object, which is an object or an instance of the driver's license class. And that will be our way for us to consider and to achieve association. We will use the services to be provided by the driver's license object inside the person class. In the person parameterized constructor, we only accept values for first name and last name, as you can see here. So why we did not include the driver's license as a parameter of the person class? The reason is, even though there is a driver's license class field defined in the person class, we did not include that because not all person is required to have a driver's license upon creation. So remember, if you will make a person object using this constructor and you ask for the driver's license, meaning to say, you always require a person to have a driver's license and you will not achieve the 0 in the 0 or 1 relationship. Okay, so that's it. A method named assign driver's license, which accepts a driver's license object here, will set the relationship between the two classes, wherein every time we create a driver's license object, we should call this method to assign the driver's license object to the person object. In the real world scenario again, no driver's license should be printed and issued unless there is already a person who passed the application requirements. Okay? So that is the reason why we created a method for assigning a driver's license for this person. Meaning to say, if we already created a person object, we are ready to assign a driver's license in the person object. Now, from driver's license to person class perspective. So earlier, we discussed the person to driver's license perspective in terms of association. So this time, we will discuss from driver's license to person class perspective. So as you can see here, we use one as its multiplicity from driver's license to person class, which means every driver's license is exactly associated to a single person only, that is the one multiplicity as shown in the given figure. So this one. In the real world scenario, it is not possible that more than one person is assigned to own a single driver's license. So that's the reason why we use one from driver's license class to person class perspective. To achieve association and to make every driver's license object aware that it is owned by a single person, you need to define a person object as a class field of the driver's license class. So this is our person object as a class field of the driver's license class. So which means by defining a driver's license object inside the person and a person object inside the driver's license class, they are aware with each other, and that is the bi-directional relationship. A parameterized constructor of the driver's license class will force that every time we make a new driver's license object, it should be owned by a single person. So unlike the person constructor, which we did not require passing a value for the driver's license object, in the driver's license constructor, we require a person object as a parameter. The reason why, again, every time we issue a driver's license, it is required that a person should own it. That's why from driver's license to person, we have this one multiplicity. In the real world scenario, a driver's license is made only when there is a person applies for it. Forcing to assign a person object when creating a driver's license object will simulate the real world scenario. So how to translate class association using the UML class diagram into the actual code? So as you can see here in the given slide, in main.java, we first created a person object that will serve as the person applying for a driver's license. By calling the constructor of the person class, we are able to assign the first name and last name of the person object. After creating the person object, a driver's license object is created. It is important to first create the person object before the driver's license object, since it is required that whenever a driver's license will be issued, there should always be the person's details who will use the driver's license. We use the constructor of the driver's license class, which accepts a person object, as a parameter to simulate the real-world situation. Additionally, to provide the relationship between the person and the driver's license object being created, notice that in the body of the constructor of the driver's license class, we assigned also the person object received as the value of the person class field of the driver's license object. The assigned driver's license method of the person class is also called passing the actual driver's license object as its parameter. This is the way to simulate and perform the class relationship, specifically association between these two objects. Now, by calling the full details method of the person object, we can print the values of the person, including the details of his or her driver's license. If we print the details of the driver's license object we created, the code shown will be used. Instead of using the person object to call the method, we use the driver's license object. As you can see in the output, we are able to print first the values of the class fields from the driver's license object, followed by the values of the class fields of the person object. Again, you are able to see here that this particular license number ABC123 with restriction number 1 is owned by John Doe. Independent life cycle between classes. To show the independent life cycle between classes, consider the given code. After creating the person and the driver's license object, we set the value of the person object to null, which means it is deleted, to delete its values. We printed the values of the driver's license object, and notice that in the output, the complete details of the driver's license object is still existing. These clearly illustrate the independence between the two objects. Meaning to say, Even we deleted the person object, still by printing the license object, we are able to get the values of the person who owns the given uh, example of the license object. Same will happen if the one we set to null is the driver's license object. The person is still existing. Keep in mind that the given example is not always the scenario. The code you will produce will always depend on how you analyze their class relationship using the UML class diagram, including its multiplicities. Try to think of some real-world scenario that will possibly make use of other multiplicities. In summary, we could say that one of the advantages of object-oriented programming language is code reuse. This reusability is possible due to the relationship between the classes. Association has a type relationship. Association establishes the relationship between two classes using through their objects. Association relationship can be 0 or 1, 1, 0 or many, 1 or many, and many to many that can be achieved by adding multiplicity adornments to the line denoting the association. We call association those relationships whose objects have independent life cycle, no whole part relationship, there is no ownership, child objects may and may not belong to another parent object. Now for this lessons activity, create a program with the following requirements. So take a straight screenshot of this given slide for you to have the guide on how will you complete the requirements. And that's it for now. Thank you for watching and hope you enjoyed this video. For inquiries, feel free to post your questions in our group chat. In our next video, we will discuss all about class aggregation. Don't forget to visit the links in the references section for more information about this lesson. See you in the next video.